Okay, let's dive into this. We're always hearing about the incredible promise of AI in industry, right? Things like predicting failures, optimizing entire supply chains, you name it. But what you don't always hear about is this kind of secret saboteur that's at work behind the scenes.
It's a huge question, isn't it? I mean, companies are investing millions, sometimes billions, hoping for this massive breakthrough. But so often, they just end up with models that are unreliable or, well, just plain wrong. So, what is really going on here?
And you know what? The culprit usually isn't the super fancy algorithm or the brilliant data scientists. It's the raw material they're being fed. It boils down to that classic computer science problem just on a massive industrial scale. Garbage in, garbage out. It's that simple. If your data is a mess, your AI is going to be a mess.
So, in this explainer, we're going to break down exactly how to solve this. First, we'll get a handle on the problem itself. Then we'll walk through, step by step, a strategy to build a foundation for AI that you can actually, trust.
All right, let's start by getting a really clear picture of what we're up against. And believe me, this isn't just about a few messy spreadsheets. We're talking about a deep, systemic issue in how industrial data is even collected and managed in the first place.
I like to think of these as the three core issues that just poison AI projects. First, you've got inconsistency. This is where one plant is measuring in Celsius, another's in Fahrenheit, or maybe they're using different labels for the same exact part. Then there's redundancy, the same sensor data getting collected twice, which totally skews and biases your models. And finally, incompleteness. This one's a killer. Critical gaps in your data, or failure events that never get labeled, which leaves your AI completely blind to the stuff that matters most.
And the real-world cost here it's significant. This is not just some technical headache for the IT department. This data chaos directly hits the bottom line. It makes your financial forecast less accurate, and it completely hides crucial insights about how different parts of the business are actually performing. So, how do we start to fight back against this mess? Well, the very first, most crucial line of defense is data validation. It's all about stopping the bad data right at the front door, before it has any chance to get in and contaminate your entire system. Here's a great way to think about it. You would never, ever let faulty parts onto your physical assembly line, right? So why on earth would you let faulty data into your AI pipeline? The principle is exactly the same. You have to catch the problems as early as humanly possible. And this is how it looks in practice. As data comes pouring in from all your sensors and machines, you validate it immediately, right there at the edge, which means as close to the source as you can get. If it fails a check, maybe the format is wrong or a value is out of range, it gets quarantined, put aside. Only the clean, validated data gets the green light to proceed for analysis and, ultimately, model training. Okay, so once we're successfully blocking the bad data, what's next? The next big step is to make sure all the good data learns to speak the same language. This is where standardization becomes absolutely critical. I mean, just look at this transformation. It's night and day. On the left, you've just got chaos. What is temp? Is that Fahrenheit, Celsius? And MTRC2? What does that even mean? But on the right, you have total clarity. Units are converted to a single standard, fields have clear, consistent names. Now, both a person and a machine learning model can understand exactly what they're looking at, instantly, no guesswork. The next challenge is just the sheer volume of it all. Industrial operations generate a literal tsunami of data. You can't just dump it all into one big bucket and hope for the best. You need a really smart architecture to handle the flood. And the solution here is what's called a layered data strategy. Basically, this means you don't have to choose between processing data instantly right where it's created or doing deep analysis in the cloud. You get to do both by using each location for what it does best. Let's break that down. At the edge, close to the machines, you handle all the immediate tasks, like that validation we talked about. This is super fast, and it saves a ton of bandwidth because you're not sending useless junk data all the way to the cloud. Then, the centralized cloud, or what's often called a lakehouse, is used for all the heavy lifting. That's where you're training complex models, managing the whole machine learning lifecycle, and keeping a full, auditable history of every piece of data. So when you combine all these pieces, that early validation, the data standardization, and a smart layered architecture, you finally arrive at the ultimate goal, an AI that is genuinely reliable, an AI that you can actually trust to help make critical business decisions. But, and this is a really important but, this is not a one-and-done fix. You don't just set this system up once and walk away.
Data systems are living things. They change. New sensors get added. Models get old and need retraining. Maintaining that trust requires constant vigilance and a real culture of data governance.
And that long-term trust is really supported by these three pillars. First, you need continuous monitoring to actively watch for subtle changes in your data or decay in your model's performance. Second, you must have audit logs so you can trace any prediction, good or bad, back to the exact data that produced it. And finally, you have to keep humans in the loop. You need those checkpoints for expert review and oversight to make sure the AI's decisions always make sense in the real world.
So, I'll leave you with this final thought. When an AI makes a critical decision, who's really responsible? Is it the algorithm, or is it the data it was fed? As AI gets woven deeper into our world, this question of accountability is everything. By focusing on data integrity from the very beginning, we're not just building better models, we're building a foundation of responsibility for the automated decisions that are going to shape all of our futures.